This is the Chapter 13 review. In Section 13.1, you had an introduction to trigonometry. You need to make sure you know all the relationships between the sides and the angles as represented by the 6 trig figures. Obviously, if I am standing here at angle A, then I am looking for the sine of angle A, and it is opposite over hypotenuse, so it would be A over C. Cosine is adjacent over hypotenuse, so it would be B over C. Tangent is opposite over adjacent, which is A over B. The cosecant is the inverse of the sine, so you just flip this, so it would be C over A. The secant is the inverse of the cosine, so it would be C over B. And the cotangent is the inverse of the tangent, so it would be B over A. Okay, now obviously if you were up at angle B, these would be different. You're never going to be standing at the 90-degree angle, so it's going to be at one of the 2 acute angles. You're going to use this information to be able to solve a triangle. You might use the trig functions, you might use Pythagorean theorem. This particular one, you have 2 sides. Remember that the leg squared plus the leg squared is going to equal the hypotenuse squared. The hypotenuse is always the side across from the right angle. So what we're looking for here is we're looking for little b, we're looking for angle A, and we're looking for angle C. So the easiest way to solve for little b would be Pythagorean theorem. So we'll use this as our scrap paper down here. So b squared, the leg squared, plus the other leg squared is equal to the hypotenuse squared. So that means b squared is going to be 16 squared minus 7 squared. So that's going to be 207. So I would take the square root of 207. And I doubt if I can divide anything. Actually, it can be divided by 3. Let's see. 3 times 69, so 207 probably can be divided by 9, okay? So this is the square root of 9 times the square root of 23, so it's going to be 3 on the square root of 23, okay? So that's what little b is, 3 on the square root of 23. Then to find the angles, you know I'm going to use inverse, so I'm going to decide where I'm going to stand. I'll just go ahead and stand right here at angle B. So if I want to find angle B, I am looking at the cosine because I know the adjacent and I know hypotenuse. So the cosine of angle B is equal to 7 over 16. Understand that's like my unknown, so I've got to move the cosine to the other side. When I do that, it becomes the inverse cosine. And I'm always going to use the inverse when I'm trying to find an angle. So I pick up my calculator and I go inverse cosine of 7 divided by 16. And it's going to give me a 64. So angle A rounds to 64 degrees. So that's what's going to go right there. If I know that angle, then it's easy for me to know this angle because those 2 acute angles would have to add up to 90. So therefore, this one is 26 because 64 plus 26 is 90. Remember, those 3 add up to 180. Okay, so that solves that triangle. All right, 13.2 has to do with angle and angle measurements. Let me get a red marker. All right, if I'm going to put 135 degrees on here, remember your standard position, your initial side is on the x-axis. So if it's positive, I'm going to go counterclockwise. So up to that is 90 degrees. So I want to go 45 degrees past the 90 degrees, okay? Oops. That means this is going to be 45 and this is going to be 45 because 90 plus 45 is 135. So that would be my angle right there. Okay, if I have a negative 170, negative angles go clockwise. Again, that's my initial side. If I go down to here, I'm at 90. If I went all the way over there, I would be at 180. So I want to go 10 degrees short of my 180. So that angle right there would be a negative 170. You need to be able to convert between degrees and radians. So first I'm going to change from degrees to radians. So I have 135 degrees. So therefore I want the degree on the bottom because I want to be able to get rid of the degrees. And I want the radians on the top. So if you remember, 180 degrees is the same as pi radians. I'm going to take 135, divide it by 180 on my calculator, and I'm going to convert it back to a fraction, and it's going to give me a 3 over 4, so I have 3 pi, because I still have that pi right there, 3 pi over 4 radians. Okay, then if I want to go from radians to degrees, I'm going to do just the opposite. I have radians on the top, so this time I want radians on the bottom and degrees on the top, because what you have on the top and the bottom cancel each other out. So that's going to cancel each other out, leaving me with just degrees. So pi radians is equal to 180 degrees. So that's technically equal to 1. Your pi and pi go away. I can divide the 2 into 180. It goes 90 times. 90 times 3 is 270, or 3 times 180 divided by 2. Okay, so 3 pi over 2 is the same as 270 degrees. For every angle, you need to be able to name a coterminal angle. Now, coterminal means angles that have the same terminal side. So if they give it to you in degrees to name a positive and negative coterminal angle, you would add 360 and you would add negative 360. So I have 140 plus 360 is going to give me 500. So that is a coterminal angle with 140. I have 140 plus a negative 360 is going to give me a negative 220, and that is a coterminal angle with 140. If they give it to you in radians, then you add 2 pi and negative 2 pi. So I have 3 pi over 5 that I'm adding 2 pi to, and I have 3 pi over 5 that I'm adding negative 2 pi to. Now the thing here is that they don't have common denominators. So you have to make them have a common denominator. The common denominator here would be 5. So I have 3 pi over 5 plus 10 pi over 5, because I'm multiplying the top and the bottom here by 5, which is going to give me 13 pi over 5. That is a coterminal angle of 3 pi over 5. This one, I'm going to again find the common denominator, which is 5, so it's going to be plus a negative 10 pi over 5, which is going to give me 7 pi, negative 7 pi over 5. All right, section 13.3, it was putting trigonometric functions of a general angle, putting those trig functions on a coordinate plane. So if I'm trying to find or graph the terminal side going through 2, 5, and I want to find the sine, the cosine, and tangent as a result of that. So here's my coordinate plane. I have the point 2, 5, which is this point right here. Now I can make a triangle out of this. This is going to be 2, and this is going to be 5. So there, and I'm always going to stand right there at the origin. Okay, so if I'm standing there and I want to find sine of theta, cosine of theta, and tangent of theta. Okay, if I'm right here, I've got to find, first thing I got to do, because I need opposite, if I'm doing sine, I need opposite and hypotenuse. So I've got to find the hypotenuse. So I have 4 plus 25, so this is going to be the square root of 29. Okay, so sine is opposite over hypotenuse. Well, I have to rationalize the denominator by multiplying the top and the bottom by the square root of 29. So I have 5 on the square root of 29 over 29. So that would be the sine of theta. Then cosine is adjacent, which is 2, over hypotenuse, which is the square root of 29. So again, I have to rationalize my denominator. So I have 2 on the square root of 29 over 29. And then for tangent, it's opposite over adjacent. So I don't have to do anything to that one. Okay, let's do another one of those. Okay, again, I'm making my coordinate plane here. One, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6. Okay, I'm going to make my triangle. I'm going to be standing right there. Okay, this is a -8 and this is a -6. I got to solve using Pythagorean theorem for my hypotenuse. So I have 64 plus 36, which is the square root of 100, so this is a 10. Now your hypotenuse is neither positive nor negative. Okay, I want to find my sine of theta, my cosine of theta, my tangent of theta. Okay, so remember I'm standing right here. So my sine would be -6 over 10, which I'm going to reduce to lowest term, so -3 over 5. Cosine is going to be a -8 over 10, adjacent over hypotenuse, which is a -4 over 5. Tangent is going to be opposite, which is -6, over adjacent, which is -8, which is going to be a +3/4, because I have a negative divided by a negative. All right. Law of sines, when you do not have a right triangle, you can still use trig to help you solve these problems. And the two ways that you do it are law of sines and law of cosines. This is law of sines. It's a proportional setup with the sine of A over little a, the sine of B over little b, the sine of C over little c. So let's say I have this problem. I'm just going to sketch it out here so that I understand what's going on in the problem. I have A, B, and C. So this angle right here is 50 degrees. I have little b, which is a side opposite angle B, and I have little a, which is a side opposite angle A. I can always use law of sines as long as I have an angle and a side opposite it. So I'm going to set it up. Sine of 50 over 10 equals, and let's say I want to solve for B first, the sine of angle B over 12. Okay, this is the only unknown I have, but because I'm trying to find a angle, you know, I'm going to use inverse. So I'm going to multiply that times that and that times that. So I have 10 times the sine of angle B is equal to 12 times the sine of 50. I can divide by 10. So I'm going to have the sine of angle B is equal to 12 times the sine of 50 divided by 10. But notice I want to solve for that, so it's going to be the inverse. So angle B is equal to the inverse sine of 12 times the sine of 50 divided by 10. So let's figure out what that is. Should be a 66.8. We'll round it to 67. So that's going to be 67 degrees. I can find angle C by taking both of those from 180. So 180 minus 50 minus 67 is going to give me a 63. Once I found that, the only unknown I have is little c. So again, I've got the sine of 50 over 10 equals, this time it'll be the sine of 63 over little c. So I cross product, c times the sine of 50 equals 10 times the sine of 63. And I'm going to divide by the sine of 50. So I have c is equal to 11.6. Okay, so that's what little c would be. So now I've used law of sines to solve this triangle. Okay, here's another one. Let's just sketch it out so that we have some reference points. So I have A, B, C, I have 45, I have 30, and I have little b, which is 20. Well, I can easily solve for c because this plus this equals 180. So I've got 180 minus 75, which is what I get when I add those two together. So angle C is 105. Obviously it's not drawn to scale, if you will. So now I set up, I need to find the other two sides. So I have the sine of 30 over 20 is equal to the sine of 45 over little a. So I have a times the sine of 30 equals 20 times the sine of 45. And then I'm going to divide by the sine of 30 to get that a by itself. Okay, so 20 times the sine of 45 divided by the sine of 30. It's going to give me little a is 28.3. Okay, so that's 28.3. Now, I cannot use Pythagorean theorem on this because it's not a right triangle. So I have to continue to do law of sine. So I have the sine of 30 over 20 is equal to, this time, the sine of 105 over little c. So I have c times the sine of 30 equals 20 times the sine of 105. So I'm going to divide both sides by the sine of 30. So 20 times the sine of 105 divided by the sine of 30 is going to tell me that little c is equal to 38.6. So we have solved for our triangle. All right, occasionally you cannot use law of sines. Again, using this is being used on something that isn't a right triangle. And you remember the law of cosines equation. So I'm going to set this up. Typically what I do is I start with the law of cosines and I'll finish with law of sines. So A, B, C. C is 65. Little a is 4 and little b is 7. Notice that I do not have a side across from C, so I cannot use law of sines on here. This is going to be little c, so my setup is going to be this. C squared is equal to 7 squared plus 4 squared minus, if you will, 2 times 7 times 4 times the cosine of 65, which is the cosine of C. So when I do this out on my calculator, I have 7 squared plus 4 squared minus parenthesis 2 times 7 times 4 times the cosine of 65, and it's going to give me C squared is equal to approximately 41.3. I'll have to take the square root, and it's going to give me 6.4. Okay, so now I've got 6.4 here. Now I could switch and do law of sines, because now I have an angle opposite a side. So I can say the sine of 65 over 6.4 is equal to the sine of angle A, which is my unknown, over little a. So I have 6.4 times the sine of angle A is equal to 4 times the sine of 65. I'm going to divide both sides by 6.4. And then I've got the sine of angle A is equal to, I'll do that on my calculator, 4 times the sine of 64 divided by 6.4 is going to give me like 0.5617, and I want the A by itself. So basically what I'm doing is I'm taking the inverse, because I'm looking for an angle, sine of 0.5617, and it's going to give me 34.2. So angle A is 34.2. So then I could find angle B by subtracting these both from 180. So 180 minus 34.2 minus 65 is going to give me 80.8. So now I've solved that triangle. All right, last one. Okay, here's a triangle where I don't have any angles to it. So little a is 11, little b is 13, and little c is 15. So I basically just have to pick one to do. The unknown is going to be an angle. So I can't do law of sines, so I have to start with law of cosines. And I'm just going to choose to have a squared over here. So we can put that, we'll go ahead and put the value for a squared. So that's going to be 11 squared is equal to 15 squared plus 13 squared minus 2 times 15 times 13 times the cosine of angle A. That right there is my unknown. Okay, so I've got 121 is equal to 15 squared plus 13 squared is going to be 394 minus 2 times 15 times 13. It's going to be 390 times the cosine of angle A. First thing I have to do is subtract 394 from both sides. Okay, so 121 minus 394 is going to give me 273 is equal to negative 390 times the cosine of angle A. Notice that's multiplied by that, so the way that I get rid of it is I divide it. What I do to one side, I have to do the other side. So 273 divided by negative 390 is going to give me a 0.7 equals the cosine of angle A. Well, there's my unknown. That's multiplied, so I got to take it to the other side. So it's the inverse cosine of 0.7 is equal to angle A. So inverse cosine of 0.7 is going to give me 45. Angle A is 45.6 degrees. Okay, so that's angle A. Now I can switch and I can do the law of sines. So I have the sine of 45.6 over 11 is equal to the sine of angle B over 13. So I have 11 times the sine of angle B is equal to 13 times the sine of 45.6. I'm going to divide here by 11. So I've got the sine of angle B is equal to but I'm going to have to use the inverse because I want to solve for angle B. So angle B is equal to the inverse sine of 13 times the sine of 45.6 divided by 11. So it's going to give me angle B is equal to a 57.6. And then all I would have to do is subtract those both from 180. So 180 minus 45.6 minus 57.6 is going to give me a 76.8 there for C. And then you've solved the triangle using both law of cosines and law of sines. All right, your review homework is on page 816 through 818, 12 through 44 even, and then number 50 and 52.